Okay, let's run a hypothesis test for a regression slope on our calculators. Now, the regression slopes on your calculator, the tests are very simple. You're either saying the slope is 0 versus it's not 0, the slope is positive, or the slope is negative. Those are your options. So, our car example, as you drive vehicles more, they tend to lose value. So as miles goes up, price should go down, so the regression slope should be a negative. So these are the appropriate hypotheses. Beta 1, the true regression slope, is 0 versus the alternative of beta 1, which we think is true, that the slope is less than 0. Significance level, let's just go with 5%. The good news for us, we already checked the conditions in the confidence interval example. So let's just run the test. Back to here. You should have the same data, so I'm just going to double check. Sure enough, L1, L2 is miles and price. Now into our tests. It's toward the bottom. This time we want the linear regression t-test. L1, L2, the alternative for beta and rho, that's the population correlation coefficient. They have the same sign, that's all. Should be negative. If you want to store the regression equation to graph it, you certainly can. You would just go into your variables, y1. We don't need it here, though, so let's just do a calculate. And here you go. Our test statistic, right there it is. Degrees of freedom, again, is n minus 2. So we had 16 paired data values, 16 points, 14 degrees of freedom. And the p-value, very, very tiny. So yes, it looks like our slope is in fact negative. So we reject the null hypothesis that the slope is 0, and then answer the question that was asked. Yeah, this is convincing evidence that as miles goes up, value goes down, since the negative slope is the alternative hypothesis that we're finding supporting evidence for. There you go. Don't make it tougher than that.